Hello, and welcome to the Fibocast, our new podcast exploring the technologies bringing the hyper-connected digital world to life. We'll be exploring the key technologies shaping our lives and assessing how enterprises can optimize operations, generate revenues, and maximize the opportunities that connected devices can enable. I'm George Malim, the managing editor of IoT Now, and I'm delighted to welcome Paul Anand, the sales director for EMEA at Fibercon. Paul's at the Network X event at the moment, gathering the latest insights, and he's broken away to speak to us. So we really appreciate Paul's time. This episode, we're assessing how 5G fixed wireless access is transforming global connectivity. It's clear the revolution is already underway, and users are seeing fiber-like performance from deployments. So let's get started. I think a key point is that we're not at the beginning of 5G FWA deployment. GSA, for example, has reported in its latest research that 162 operators in 75 countries have launched or soft-launched 5G FWA services based on 3GPP standards. That amounts to just over 46% of operators who have launched 5G services. And I think that truly demonstrates the appeal and traction that 5G FWA has. And I would imagine that those figures, which go up to the end of July this year, have already increased, and we're probably over the halfway mark in terms of deployment now. Of course, that means there's still another 50% to go until the entire market is fully addressed. And I'm sure that will happen over the coming years. It's clear, obviously, also that when half the market is doing something, it's reached a stage of maturity, recognition, and acceptance that only leads to more growth. The next step will be to follow through that adoption curve with revenues, which we're also seeing increase sharply. And I think Paul will have more to say on that topic later on in the podcast. So let's turn to the meat of today's discussion and take advantage of Paul's expertise to discuss the next stage of 5G FWA deployment. Let's take it from the top, Paul. Could you introduce what FWA is and explain its benefits? Over to you, Paul.
Thank you, George. Hello, everyone. FWA is a technology that provides broadband internet access to home and business using 4G and 5G cellular networks rather than the traditional wired connections like fiber or cable. There are three benefits for the telecom operators. First, they can quickly deploy. The FWA can be installed faster than traditional wired solutions, making it a great option for rapidly expanding regions where wired infrastructure is lacking. Two, the cost effectiveness. It can be more affordable to deploy in rural and underserved areas compared to laying extensive fiber or cable networks. And finally, the scalability. As demand increases, FWA networks can be expanded more easily without the need for extensive physical infrastructure. And for the users, the benefits are primarily the high-speed connectivity. FWA can offer high-speed internet access comparable to wired connections, making it suitable for various applications like streaming, gaming, and remote work. Mobility, while primarily fixed, some FWA solutions allow for limited mobility, providing users with some flexibility in how they access the internet. Overall, FWA serves as an effective solution for providing reliable internet access in a variety of settings, particularly in areas where traditional broadband options are not feasible.
So what are the commonly seen FWA devices, Paul?
There are four commonly seen FWA devices. I will start with the USB dongles. These were the very first devices that started to be launched in the year 2000, providing to laptops wireless access to the internet. The limitation of such devices were a single user capability and also reduced performance due to the USB power capacity and antenna challenges in a small casing environment. The successor, the mobile hotspot, these portable devices are specifically designed to create a Wi-Fi network using a cellular data connection. They usually have a battery, allowing for mobility and can connect multiple devices simultaneously. And finally, the indoor CPEs, indoor customer premises equipments devices, functions as routers, allowing multiple devices like computers, smartphones, and smart home devices to connect to the internet They have built-in Wi-Fi functionality and they often come with Ethernet ports, enabling wired connections to devices for more stable and faster internet access. One variant of the CPEs was launched also with the outdoor version. Installed outside of a building, the outdoor CPE is designed to enhance signal strength and reliability. In this podcast, we will focus on indoor and outdoor CPE devices.
Okay, Paul. So, I guess a key point is to understand how much 5G is out there in the market. So, what's the status of 5G network deployments across the world?
Yeah, the FWA service is provided by telecom operators either on 4G or 5G cellular networks. As of 2024, 5G network coverage has expanded significantly across the globe, but the extent of coverage varies widely by region and country. Here is an overview of the current state of 5G network coverage. The United States and Canada have made substantial progress, with major carriers deploying 5G networks in urban and suburban areas. In Europe, many European countries have launched 5G networks, with leading countries like Germany, the UK, and France seeing significant coverage. However, rural areas often still rely on 4G. In Asia, South Korea was one of the first countries to roll out 5G extensively. China has also rapidly expanded its 5G network, aiming for national coverage, while Japan and India are making strides as well. The Middle East, countries like the UAE and Saudi Arabia have made significant investments in 5G technology, offering extensive coverage in major cities. Africa, 5G is still in the early stages in many African countries, though South Africa has launched 5G services in urban areas. Other countries are gradually rolling out their networks. Coverage is expected to continue expanding over the next few years with investments from telecom companies. Today, 332 carriers worldwide have launched commercial 5G services.
Could you provide us some insights on the status of FWA service by quantity, Paul?
Sure. By 2020, 15 million of units were deployed. 2/3 of these devices were based on LTE and 1/3 was based on LTE advanced technology. 5G FWA devices were starting to be rolled out. In 2021, 5G FWA devices started to be more important, around 3 million units, while the number of 4G devices was stable. In 2022-2023, we reached the milestone of 25 million units. 5G FWA device numbers continued to grow in a steady manner by reaching around 10 million units, while the number of 4G devices stagnate at 15 million units. By 2029, the projection of CPE devices is about 40 million units. From 2024, the total shipment of 4G CPEs start to decline, and the driving force for the market to continue to grow will come from the large-scale shipment of 5G CPE to fill in the decline of 4G and the self-growth of 5G.
Okay, so we've seen that 5G network deployment is diverse in different markets across the world. What about the geographical deployment of 5G FWA devices? How does that look, Paul?
The top 3 regions that have adopted indoor CPEs are North America, APAC, and Middle East. In North America, the 3 carriers have deployed a couple of generations of CPEs, indoor CPEs, and nowadays there are around 5 million devices deployed. The second region, in APAC, Japan is leading with 2 million units, and followed by Australia and New Zealand and other countries in Asia, where we can see a total of 5 million units also. And finally, in the top 3, we have Middle East, which has deployed around 2 million units. Now, if we look at the rest of the world, Europe has deployed around 1 million units, and India is starting to propose FWA services.
We mentioned that indoor CPEs provide high-speed internet connections to the home, but what about the business segment users? How is that developing?
Yeah, the indoor CPEs are also deployed in small and medium enterprises. These devices are used to provide internet connectivity and networking solutions within the premises of a business. These devices are crucial for ensuring that SMEs have reliable internet access, and can effectively manage their internal networks. Here is an overview. The indoor CPEs function as routers, allowing multiple devices within the office, computers, printers, and smart devices to connect to the internet simultaneously. These typically include built-in Wi-Fi capabilities, enabling wireless connectivity for employees and guests within the office space. They often include advanced security protocols to protect the network from the unauthorized access, ensuring data privacy and integrity. Many models offer user-friendly interfaces for easy setup and management, allowing businesses to monitor performance and troubleshoot issues without extensive technical knowledge. Since indoor CPE devices come with features that support voice over Internet Protocol services, allowing businesses to make calls over the Internet. The benefits for the SMEs are, first, cost effectiveness. Indoor CPEs are generally affordable and can help SMEs save on operation costs for providing reliable Internet access and reducing the need for multiple devices. Two, improved productivity. Reliable internet connectivity enables smoother operations, better communication, and access to cloud-based applications, enhancing overall productivity. Scalability. As SMEs grow, they can easily expand their network capabilities by upgrading or adding additional indoor CPE devices to accommodate more users and devices. Flexibility. With built-in Wi-Fi and routing capabilities, employees can work from various locations within the office, facilitating a more flexible work environment. And finally, the remote management. Many indoor CPE devices allow for remote management, enabling IT staff to monitor and configure network settings from anywhere.
Okay, so let's go back to the basics of the technology. You explained that 4G CPE device deployment will be replaced by 5G CPE eventually, in spite of the fact that 5G is a new technology and will have a longer life cycle than 4G. What do you see as the particular technical reasons for a higher number of 5G CPE being deployed?
Yeah, first of all, let's have a look on how 5G technology was designed and how it was deployed. In fact, it was deployed by two steps. The step one, which we call the 5G non-standalone, also called NSA mode, that relies on existing 4G infrastructure for signaling and control functions, offering improved speeds and latency, but not fully utilizing the capabilities of 5G. And then the step two was the 5G standalone, also called SA mode, that operates independently of existing 4G LTE networks. This means it utilizes its own dedicated infrastructure and does not rely on 4G for any part of the communication process. Here are some key features and benefits of 5G SA networks. The 5G SA networks support advanced features and capabilities like enhanced mobile broadband, EMBB, in other words, more data throughput. Ultra-reliable low-latency communication, URLLC, allowing for faster response times in applications that require real-time communication. The network slicing, allowing operators to create multiple virtual networks within the same physical infrastructure, each optimized for different type of services or users. Massive machine type communication, MMTC, enabling new applications like smart cities, autonomous vehicles, and IoT solutions. And finally, increased capacity. 5G SA can support a higher number of connected devices and greater data throughput, making it ideal for dense urban environments and IoT applications. Overall, 5G SA networks are essential for unlocking the full potential of 5G technology, enabling innovative applications and services that require high speed, low latency, and reliable connectivity. As of today, 35 telecom carriers in Asia, Europe, Australia, North America, and Latin America have already launched commercial services on 5G SA mode.
So now that 5G has reached maturity from the technological point of view to address the user demand for high-speed internet, how do you see the next stage of evolution of 5G?
Yeah, 5G technology is now definitely meeting the demand for good quality internet services. So the next evolutions would provide more services beyond the simple high-speed internet connection. I believe that indoor CPE will become a unique gateway for internet experience and for IoT sensors. Indoor CPEs are now embedding Matter, the new standard for home automation. Matter is an open source, universal connectivity standard designed to improve compatibility and communication among smart home devices and IoT products. Matter aims to simplify the smart home ecosystem by ensuring that devices from different manufacturers can work together seamlessly. Users can now connect directly the Matter IoT sensors to the indoor CPE. So there is a kind of convergence between broadband and IoT connected objects with this evolution. The second is the Edge AI. The AI-powered 5G FWA devices integrates now LLM, large language models, automatic speech recognition, and text-to-speech from both edge devices and the cloud, allowing flexible resource allocation judged by various computation requirements in different scenarios, advancing the capabilities of 5G FWA devices as well as opening new possibilities to 5G home internet scenarios. The 5G AI FWA solution is designed to utilize AI intelligence to understand and respond to users' requests and streamline task management processes through voice input and text messages to OpenAI's Whisper service on the conversations can be realized through the web interface, offering seamless, intuitive communication system significantly expands the CPE capability and improves user experience. The AI-powered FWA solution also extends its intelligence to network optimization, latency reduction to meet customer satisfaction, serving as a hub for unified task management. The telecom operators will also benefit from Edge AI capabilities. Now they will have more tools to provide the after-sales support. They will get more metrics on the customer usage. They can provide more tailored services, and they can shorten the troubleshooting time. Then we have the millimeter wave 5G. Though the millimeter wave 5G was defined at the initial stage of the 5G technology, they are not massively deployed right now. So the 5G technology refers to the use of extremely high frequency radio waves in the 24 gigahertz range. It is one of the key components of 5G technology, known for its ability to provide ultra-fast data speeds and high capacity. Millimeter wave can deliver significantly faster data rates compared to lower frequency bands called sub-6 or below 6 gigahertz due to large bandwidth available for use, often exceeding 1 gigabit per second and potentially reaching up to 10 gigabit per second or more in optimal conditions. The primary limitations of millimeter wave is its shorter range and reduced ability to penetrate obstacles like buildings and trees. So this means that millimeter wave technology will be used only on outdoor CPE devices. The RedCap 5G. 5G RedCap, or reduced capability, is a specification within the 5G framework designed to support devices that require less complexity and low power consumption than full-fledged 5G devices. It is particularly aimed at use cases like IoT, Internet of Things applications, wearables, and other connected devices that do not need the high data rates or extensive capabilities of standard 5G devices. Despite the fact that RedCap is targeting the massive IoT applications with lower throughput, this technology is suitable for addressing the low-end market of FWA. With throughput comparable to LTE Advanced and with all 5G enhancements like low latency, RedCap FWA devices will replace the current 4G, LTE, and LTE markets. As I said before, the current forecast for this kind of RedCap technology by 2028 will be in the range of 500,000 devices deployed in the world.
Thank you, Paul. What is Fibercom's role in the 5G FWA marketplace?
Yeah, Fibercom offers a comprehensive 5G modules portfolio powered by latest chipsets from leading SoC providers like Qualcomm and MediaTek. Our portfolio is composed of sub-6, millimeter wave, and RedCap modules, but it's not only about the cellular connectivity when you are designing FWA. It's an overall customer experience that we need to provide with Wi-Fi capabilities. So that's the reason why we have also invested on additional technologies like Wi-Fi 6 and 7, Matter, and Fibercom has successfully deployed the innovative 5G FWA solutions to the world's tier 1 carrier use cases in these scenarios, such as in home connectivity and small and medium businesses.
Great, thank you, Paul. That was a really interesting explanation of what's going on in 5G FWA, and I'm sure we're going to see a lot more traction coming through in the coming years, particularly as people move away from traditional fixed networks and also move up the cellular Gs into the next generation. We've reached the end of today's Fibocast, the first in the new series. So many thanks for listening, and thanks also to Paul Anand from Fibercon for sharing his insights. We look forward to welcoming you to the next Fibocast soon. But in the meantime, please share your comments and look out on social channels for more information and the upcoming topics that we'll be covering in the series. Thanks again for listening today, and goodbye.